So we're now taking a look at the change of variables formula, or you can call it the composition rule for limits. And we formulate it in the following way. So we're being careful here. So assume that the composition here is defined in a punctured neighborhood of x equals to a. Then the limit as x tends to a, g of x equals to b, and the limit as u tends to b of f of u equal to L implies that the limit of the composition as x tends towards a is equal to L. So we're not going to do the full proof here, but I'll indicate how to start. So let's do here proof like this. And as with most of these proofs for these rules in the rule books, half the battle is basically figuring out what it is that you know and what it is that you need to prove. So let's write out what we know. And here, let me just be rather sloppy and leave the rest as an exercise. So what we know here is that for every epsilon 1, then x minus a small implies g of x minus b less than epsilon 1. For every epsilon 2, we know that if u minus b is small, then we get f of u minus L, well, small. So I'm doing really like a hybrid hand waving here, slightly on the rigorous side, slightly not. So this we know. And what do we need to prove? Well, it's this, right? So we need to show that when, for every epsilon, then x minus a small implies that f of g of x minus L is smaller than this epsilon. And here, if I want to keep things a bit separate or to indicate the difference, here I put my green epsilon. So this is my challenge. This is the arbitrary guy who I should consider fixed and unknown. These guys here I can choose to be whatever I want, and in particular it can depend on the epsilon. Now, in this proof, what really is a challenge is to keep track of all the bookkeeping. So I can make a figure here to help you out. So you basically have three axes here involved. So you have the x-axis, where you can say that g takes its input. Then you have the u-axis, where f takes its input. And then let's call it the y-axis, where f gives its output. And here, down on the x-axis, you have your point A, and the point here, and then on the u-axis, you have your point B, so it's the value of g, and up here, you have your L, which is the value of f. And what we want to show is that as x gets closer to A, well, then we know the corresponding u's gets closer to B, and then what we want to show is that if we feed these into f, then being close to B means that we're close to L. But of course, we know separately that f sends stuff close to B, stuff to L, and we know that G sends stuff close to A. So we should be in good shape. And the logic here is that we begin with this, right? So this is the start. This means that we begin with an epsilon challenge around L. What should the next step be? Well, the next step should be to figure out how close do we have to be here for f to send points inside of the L. So this will give us some type of delta answer here. Now you know that whatever falls inside of here, f sends there. Now you can take this delta answer here to be the epsilon challenge for g. So then when you find your delta answer to this epsilon challenge that used to be a delta answer itself, well, then you know that, okay, g will now send everything here inside of here, and now composed with f, everything will be sent here. So if you write down basically what I said now, then you have your proof for this result.